Ready. Ready. Ready.
Hello, welcome to Enlightning. I'm so excited for today's episode. I'm here with Jonah Kowall, who's going to teach us about Jaeger. Jonah, will you introduce yourself, please?
Sure. My name's Jonah Kowall, and I'm happy to join you today and speak about the Jaeger project. Personally, my background is as a technologist running high-scale production systems as a practitioner in security and operations. I've been an analyst at Gartner studying the observability and monitoring space. And for the last decade or so, building products and working at vendors that deliver observability and data solutions. So thanks for having me on.
That's an illustrious career. You've done a lot of cool stuff. Do you have what's one of your favorite jobs of all of those different angles that you've been around tech?
Yeah, I mean, I like really building successful teams, which I've done in a lot of different places and different areas. It's really about mentoring people and building those teams. So I really love building product teams and engineering teams. That tends to be where I spend my time, but I also have a big heart for open source, both as a user and a lot of contributions. So that's where I spend my free time.
One more question about your job, and then we'll dig into the tech. But
Yeah.
What do you look for since you love building teams, when you're hiring a person with a team in mind? What kind of team qualities are you looking for?
Yeah, I mean, so for me, it's really important to be aligned with the founders. I tend to work at startups or startups that
Okay.
get acquired. So that's important to me. And then capturing what the founder wants the company to be about in the people that I hire. So for me, it's aside from the skills that they're going to have to do the job, it's about the mentality and the approach. And I also want people that are going to take initiative, because as a leader, I'm not a dictator. My goal is to really help that person be successful and to learn from them the same way that they learn from me. So a lot of it's really about mentorship and enabling people to be their best at the role that they're in.
That's awesome.
Yeah.
Cool. Well, thank you so much for coming on today to teach about Jaeger.
Sure.
Those in the chat, if you feel like saying hi, I love knowing you're there and where you're from, and whether you have experience with Jaeger or with distributed tracing generally. I'm going to be honest, I don't know of any other distributed tracing software. Like maybe Jaeger's doing such a good job. I can't even name another tech that does it. Oh, lots of friends are here. Hello, hello. We have Nikos here from Greece. Hello. I like your little avatar, Nikos. And then Epic Tralala's here too. Hi. So good job, Jaeger, for being the name in the game with distributed tracing.
Well, I mean, we can talk about where it comes from and get into all that because it's actually been around for quite some time.
Cool. Yeah. So what I love to start with is like, what was the world like before Jaeger existed? Like, why did it get created? Give me some context.
Yeah,
What problem
so
is it solving?
if we go back a couple of decades, when folks started building things in Java, when Java came out, we sort of started to create complex distributed systems where you used to have big pieces of software. We started making them smaller and smaller. These aren't microservices, but that's kind of what started the trend. And so because of Java, we started to have all of these different applications talking to each other. Going back, 20 plus years, things like Corba and Orb were like ways that applications interacted with each other. And some really smart people said, it's really hard to debug these things when you're dealing with complex systems because there's so many interdependencies, and it's not just the code, it's really how they interact with each other. So it really started with distributed applications. Fast forward to basically what Uber was doing and Netflix were doing back at the start of the companies is they took that paradigm to a completely new level, what we now know and call microservices architectures, where these applications became even smaller, which meant that we had even more calls, transactions going between different components. So that made the problem a lot worse. So that used to do distributed tracing back when we had bigger Java applications were really expensive. So for a company like Uber or Netflix, it just didn't make cost sense for them to go and buy those commercial products. And they couldn't deal with the scale that they were operating at, because when you go and request a ride at Uber, or you look at your, what you want to see in Netflix, there's many, many, many transactions going on just for that one click of a button that you're doing. And these transaction tracing systems needed to follow all of those different paths for all of the transactions that these users were doing.
So this is, I'm already learning so much. So this problem started before Kubernetes, before distributed systems, before microservices.
Well, before distributed systems were really the start of the problem. And if you go back to kind of historically who invented distributed tracing, it was really mostly done around Java. You could argue that there were some old mainframe technologies that would do this stuff back in the 1980s, but it really became a bigger problem in a market. There's a company that, if you want to look at the history, you're familiar with New Relic, right? The APM, monitoring company.
I've heard the words New Relic. I don't know what APM stands for. Yeah.
They're a popular company, but the founder of New Relic actually founded a company before that called Wiley Technologies, which was kind of the first Java distributed tracing system. He sold that to Computer Associates, which is now actually part of Broadcom, your colleagues. And that was kind of the first distributed tracing system. He then went to found New Relic as a SaaS distributed tracing system. But at the same time, AppDynamics was founded. Dynatrace moved from being a debugging tool for developers to a production tool. So those three companies really are what ignited distributed tracing in terms of a market. And there's still, it's a multi-billion-dollar market when you just look at those three companies alone. It's 4 or 5 billion.
Yeah, I could see that there's a tremendous need for visibility in what's happening and with this level of complexity. In fact, folks in chat, what are y'all doing in terms of distributed tracing? I'd love to hear what solutions you're working with right now.
Some people may call it APM. That's like the application performance monitoring. That is distributed tracing with a little bit of other pieces, but a lot of people know APM as like when you go and buy a product from Datadog or New Relic or Dynatrace, it's usually called APM. And a component of that, or the main component of it, is distributed tracing. So, if you were to look at the research from Gartner or things like that, it's usually under that APM moniker. But distributed tracing is kind of a lighter weight, simpler approach to what you get in APM, which has a lot of other pieces and value that it provides.
Okay, APM. I'm learning.
Yep.
And
So
I know.
you kind of, when you think about monitoring, everyone that writes code deals with logs. And then you say, hey,
Yes.
I need some metrics to start looking at my production system. When is my latency going up? Looking at some metrics and numbers. And then when you want to start doing more sophisticated debugging, you need distributed tracing, which kind of provides the glue between the user and the transaction, the metrics that you're looking at, and the logs. So the trace is basically the glue, between those different pieces of monitoring.
Okay, I definitely want to capture that, but I think
Sure.
before I do, Nico says they use Dynatrace and Datadog, and in the old days also Jaeger. Is Jaeger part of those solutions, like under the hood? No. Okay.
I mean, so when Jaeger started, which was created at Uber to deal with the scale of microservices that they had, these other tools existed, not Datadog, but Dynatrace did, and certainly other tools. But the cost and the scale was too large for what Uber was doing. I was at AppDynamics quite early, and I was there for some time. Netflix was an early AppDynamics customer, but the scale got too big of Netflix. So they decided to go and build their own tool because we just couldn't scale. But they were a customer that really helped us move forward at AppDynamics in terms of scale and features. And then they just outgrew us because, as you know, all these companies just started booming, and the volumes that they were dealing with were just massive. So it was a cost problem and a complexity problem. And and then Uber decided to create Jaeger internally for them to solve this problem. Eventually Uber, they did make it open source, but it was still part of Uber. And then they donated it to the CNCF as a project. And we still have a couple of people working on the project that are either former Uber, like Yuri, who's the creator of Jaeger. He is now at Meta, but he was at Uber and created Jaeger when he was there. He's also written books on distributed tracing, and he's part of the OpenTelemetry project. He's a maintainer as well. So instrumentation, which we can get into, is a core part of how distributed tracing works.
Okay. So what I want to answer first is I want a succinct definition for like what is Jaeger, or maybe before what is Jaeger, do we need a what is distributed tracing? But I feel like that's probably going to be more complex.
It's pretty simple, but I think it's kind of important to understand like a couple of the fundamental constructs of it. Which is, what is a trace? Is probably the first thing. So when you, sorry.
Let's put what is Jaeger on the board, and then we'll pick apart our definition and explain everything in the definition.
That's fine.
Okay.
Yeah. Do you want to know what Jaeger is today, or what Jaeger was when it started and how it's evolved?
I want to know. Is there room for it on the board? Do you have a sense of like what kind of story, or do you just want to talk about?
Yeah. So I mean, when Jaeger started, it included the instrumentation, which is basically the way that you collect traces from code. It included that part. That was then spun out into what is now called OpenTelemetry.
Okay.
So Jaeger now leverages OpenTelemetry for data collection from the application. So when it started, it had its own SDKs and APIs using something called open tracing, which was a standard before OpenTelemetry. OpenTelemetry subsumed that project and now is the main way that we get data from applications into Jaeger. So when you look at it, you look at the application, which then has instrumentation, and then Jaeger is the system that collects and visualizes that data.
Okay.
Yeah.
So let's get a Jaeger. What is Jaeger? Jaeger is...
So the main parts of Jaeger are basically the storage system. So a place to store traces.
Okay. Let's get a definition before we talk about like the components. Like, what is Jaeger? Like, Jaeger is
it's a distributed tracing system designed to collect and visualize traces.
Okay. I love it. This is exactly.
You could say it's actually collect or store, or you could say collect and store and visualize. So it's storage and visualization, which are kind of
collect, store, and visualize.
Yeah, that's probably the best definition of current state.
Traces?
Yeah. Yep.
Okay. And then Jaeger leverages OpenTelemetry to collect data?
OpenTelemetry provides the instrumentation that Jaeger collects. So you as a developer use OpenTelemetry, and then you can send that data to Jaeger and to various other tools.
Leverages OpenTelemetry to instrument applications.
Yep.
To send data to Jaeger.
Instrument applications to generate the data that Jaeger collects technically.
Okay.
Yeah. I mean, more specifically, trace data, but it sometimes does metrics too. It's a bit, just keep it simple, maybe.
Okay. So this is great, but now I think it's time to say, what is a trace or what is tracing?
Yep. Okay, so let's talk about that. So a trace is an end-to-end transaction. So when you think about it, when you click the checkout button on your favorite website because you're buying something, what does that checkout button do? It likely does a bunch of different things behind the scenes, but that would be a single trace. So it's a distributed end-to-end transaction.
Okay.
And inside that trace, all of those little pieces that go into it, the different steps that it goes through, are called spans.
Okay.
So multiple spans make up a trace.
Each step.
Yeah, or
called a span. So maybe I think what would be helpful is to be like you said, is to have examples. So the end-to-end transaction, what's an example of an entire trace?
So let's say you click a checkout button in your application, that could be a trace. That's my checkout transaction trace, for example. Or order ride, or login, or kind of anything that you think about the user doing, or it could be not done by a user. It could be between two systems.
So if an end-to-end is a checkout transaction, then what would a span be within a checkout transaction?
So like, let's say you're maybe calling a billing system to charge your credit card. That could be a span where I'm calling Stripe and telling them, hey, bill this user for this transaction. Maybe I'm making a call to UPS to say, generate a shipping label for the transaction. Maybe I'm making a call to another system that is my warehouse that tells them to go and fetch something out of the warehouse and prepare it to be sent. These are all kind of little things that could be spans inside that bigger transaction that occurs. But many of those things could in themselves be several spans. It may not be so simple depending on how the system is architected.
Yeah, like the call to UPS might be one span and the generating the label might be a second span.
Could be, but it could be a lot more complex than that, where maybe you have to call multiple systems and, it all depends on the architecture of the application. So distributed tracing is a great way to understand what an application actually does. I mean, that's the big thing that it provides, is a blueprint to the application, because if let's say you acquire a company, you have no idea what their applications do, how they work. They may not even know how they work. And by using this technology, which is one of the main reasons I was really interested in it, you can really unpack what the application does, where the inefficiencies are. There's all kinds of great use cases for this data.
So for tracing in general, it can be distributed. You have an end-to-end transaction. That's what a trace shows you. And then each step is called a span.
Yeah.
And then it helps you altogether. It helps you understand what an application actually does if you trace the calls going through, as opposed to like trying to infer from reading the code. And you can also see the performance.
I mean, the main reason that you get it is that you collect this information is to get timing. So you know how much time each of those steps took. So the main problem that people use this for to debug is, the CEO calls and says, hey, when the customers are checking out, it's taking 20 seconds. What's going on, right? How do you solve that problem when we know the checkout transaction calls 15 different things managed by 15 different teams? And meanwhile, the customer is upset that things are slow. So how do we fix that problem? We pull up the distributed trace. We see that it's taking 20 seconds. And we know, UPS is slow. Let's call UPS and say, hey, your API is running very slowly today. We're seeing a lot of latency and it's affecting our customers. When are you going to have that resolved? Or it could be another team that's maybe managing a database that's running slowly. And now you have some empirical evidence to share with them that says, when we do this and we submit this type of transaction, we're seeing this error or this latency specifically. Because some of the really tricky stuff, it's like maybe only users in Germany are seeing slowness, right? And it could be something to do with how the application works in Germany that's different than how it works in the UK or something like that.
So you can really get fine-grained information from this. I see. I want to acknowledge Napalm Codes is here. Hello, and hello, Vamshi. Napalm Codes says this is timely. They're fighting a battle of volume versus eliminating too much detail from APM that reduces ability to troubleshoot. So when we were just saying this is really fine-grained, I had like there must be a compute cost to the fact that this is so fine-grained.
So it's less about the compute cost to generate it and more about the cost to store it and analyze it. So Napalm Codes, what he or she is talking about is that one of the techniques that we use in distributed tracing, whether it's commercial or open source, is something called sampling. which is
Okay.
where we decide what to keep and what not to keep, right? So think about the issues that we're talking about. If the application is running great and the performance is good and everything's running fine, why should I keep everything all the time?
Yeah.
The value is pretty low. Whereas
Uh-huh.
when the application's having problems, something's running slow or there's other challenges, I want to keep that data because I'm going to need to debug something or understand what's happening. So sampling is a very challenging part of any distributed tracing system. When you purchase an APM tool, they do a lot of that for you. When you use open source and do it yourself, you kind of have to make decisions as to how you sample, what you collect, what you don't collect. You still have control over it in commercial tools, but they provide better guidance of what you should sample. Whereas in open source, it's kind of up to the user to solve some of those problems.
So the compute cost of tracing comes from the collecting and the visualizing, or the storing, the collecting and the storing?
It's mostly storing and then visualizing, but largely the storing side of things. The volume of data can get very large, just like log files can, and it's a big challenge for sure.
And so therefore you use sampling.
Yep. And there's a lot of different, I mean, you could probably do a whole episode on sampling. There's a lot of different ways to go about doing it, and each have pros and cons and trade-offs. And this is more of an open telemetry topic when you talk about sampling, because it's done in the open telemetry layer is where sampling occurs. But it's still, very common problem that people come to the channel with and ask questions about. Napalm Codes wants to do an episode on sampling.
I'm doing a whole series on everything observability related, so maybe sampling will be in there.
One. Yeah.
Definitely
a good one.
Napalm Codes. I was literally trying to convince my colleagues that's what we need to look at today. Wow, what are the chances? Changing.
Well, always on means you're not sampling. So that's basically collect everything all the time, and eventually that becomes expensive, depending on the scale of your company. And as the company scales and grows, sampling is something that you have to start adding, and you're going to continue tuning it. I mean, at Uber, they came up with some really novel ways to do sampling. That are a bit unique. I don't think a lot of people do it the way they do at Uber, but there's lots of great ways to do sampling today.
Cool. Well, we'll just note that it's a thing and an important thing, but we won't get into it because, as you said, it's more of an open telemetry thing. And
sure.
We opened a can of worms when we were talking about Jaeger, that I closed the can of worms, and now I'd like to open it again. And that is, you were starting to say, like, Jaeger's made up of these components, 2 main components, you said, but so let's go back to that.
Yeah, sure. I mean, I would say the two, like, without getting into, it's of course a microservices application, so you can scale Jaeger as you break out different components to it. So depending on what you need to scale, you can basically add more services and scale it horizontally. But the main 2 pieces are basically the storage, the database, where you're keeping this data, and the visualization, which is what users use to interact with the data that's stored.
2 main pieces of Jaeger. So, and so the storage and the visualization. So first is storage. Let's talk about storage a little bit. How does Jaeger store data?
Yeah, so officially are supported backends. So a backend is basically a database. We support Elasticsearch, OpenSearch, and Cassandra today.
Okay.
So those are just databases. We also have, well, we're almost going to have official support for ClickHouse as well, which is another database.
Elasticsearch, Cassandra, what was the second one you said?
OpenSearch, which is the open source version of Elasticsearch.
Cassandra.
Yeah.
And almost ClickHouse.
Yeah, you can put ClickHouse on there. I mean, it's coming pretty soon. We have a huge list of unsupported storage systems as well that you can find on GitHub, where people have written storage support into various systems. A lot of open source storage systems also support it, but I would say the most popular is definitely the Elasticsearch OpenSearch. However, ClickHouse is very efficient. So if you're looking at implementing Jaeger today and you don't have Elasticsearch and OpenSearch, then ClickHouse is a great option just because it helps really keep the cost down due to the way it compresses data. So if you were to ask me what backend I should use, I would probably start with ClickHouse unless you have Elasticsearch or OpenSearch, or you're looking to do more than just run Jaeger. I work on OpenSearch as well. That's another project that's popular for logs and traces.
I have a question. So Jaeger, okay. So there's an application. It's instrumented with OpenTelemetry so that it sends data in a standardized format that Jaeger can use. And then Jaeger takes this data and sends it to a storage backend.
Yep.
Why is Jaeger needed? Why doesn't the OpenTelemetry send it to the storage backend?
Because OpenTelemetry is about data collection. It does send it to Jaeger, but Jaeger is basically a backend for OpenTelemetry, the same way that Datadog or New Relic or Dynatrace would be.
So is it processing the data in some way?
OpenTelemetry can do some processing, like sampling, which we were just talking about, and it could do filtering and a few other things. But generally, it basically standardizes the way that the data is collected from the application and makes it so that you can send it to one or more different backend systems. So let's say you're using Datadog today and you want to try out Jaeger. You just configure your OpenTelemetry to send it to Datadog and to Jaeger, and you can experiment with both. In the old days, before OpenTelemetry, we used to have to take all the instrumentation out, put new instrumentation in. It was very expensive and problematic. And all of the vendors used to have to build their own instrumentation. I can tell you at AppDynamics, we had over 200 engineers just building instrumentation. And New Relic had the same, and Datadog has the same. And so instead, we all said, hey, everyone works on OpenTelemetry. It becomes the standard. And now we don't have to worry about that part of the problem so much. So now people focus on the storage and the visualization and the value of the data instead of just collecting it.
Okay. So Jaeger helps get the trace data to storage, and then Jaeger also helps with visualization. Will you say more about that?
Yeah, so Jaeger has a UI that allows you to basically search through the data, filter it, sort it, analyze it, really understand where the problems are. And it looks at traces and also does some work with metrics as well.
So Jaeger has a UI that helps you. Will you say all those verbs again?
Yeah, sure. It helps you analyze the trace data to really understand where the problems are, and also to visualize the application topology. So it's basically analysis and visualization that's inside Jaeger UI.
Also a visualized application topology.
Yeah. It has other features too, but largely it's really about analyzing, searching, and visualizing.
So is this, so what I'm understanding so far is like this seems to be used for troubleshooting. Like, is there anything, this seems to be like very human and very like, I have questions, I'm going to go to this dashboard for answers. When do you, is there a case, and when is that case where you just like are automatically getting data that you're not even asking for, that you're like building something that you just want to monitor?
Yeah, so 2 or 3 years ago, we added a new component to Jaeger's visualization, which is called service performance monitoring. And what that does is that we basically take metrics from OpenTelemetry, and we use those to understand when an application is starting to go the wrong way. So what I mean by that is you typically look at a few different metrics when it comes to application performance. It's basically the request rate. How many requests per second am I getting? The error rate. How many errors per second, per minute am I getting? And the latency. So is the application slowing down? Is it trending the wrong way? So we got this data into Jaeger to help people start to use that proactively. Jaeger is not a monitoring tool. You typically will have a metric system based on Prometheus or something else, which does that type of alerting. So ideally, you set up your alerts in Prometheus that notify the user when the application is starting to go the wrong way. The error rate's increasing, notify the team. The latency is increasing, notify the team. We visualize it in Jaeger, but most people using Prometheus also visualize those same metrics in Grafana as well. So we built that in OpenTelemetry to unlock this use case of application performance, and now tons of people use it for various things. But we built that upstream to specifically, unlock these use cases of application performance monitoring.
Vemshi is a fan of SPM. For when Vemshi put that comment up, I'm like, SPM, and then I put it together.
Exactly. Yeah.
So SPM isn't just about tracing service performance monitoring. It's also using metrics.
Yeah,
and then it can provide alerts.
So in OpenTelemetry, we actually built something that looks at the traces, which contain things like latency, and then we derive the metric from the trace. So we built that in OpenTelemetry specifically to create the metrics from the traces. So it's a little bit, it utilizes traces to build metrics about application performance. And then those are stored in your metric system because Jaeger is not a metric system. So Prometheus is obviously the most popular one, but there's all kinds of other, vendors that build great metric systems too.
So in Enlightning, we've covered a general episode about observability, which we did like a long time ago, over a year ago, and similarly a general episode about OpenTelemetry a long time ago.
Okay.
And then last week we covered logging, we covered Fluentd and logging operator.
Okay.
And so I'm still kind of like, so I understand like logs, metrics, traces are the three pillars of observability.
For now.
And
there's more coming.
For now. Oh, fascinating. And even I had even kind of thought it was like metrics build on logs, tracing builds on everything, or kind of
no, I mean
that's not quite right. Yeah.
No, I mean metrics are really their own data source, but a metric can be derived from a trace or a log, or you can just generate a metric. Like your thermostat generates metrics. I mean, that's what it does. It tells you what the temperature is. But if you don't have that ability to generate it, you can also derive a metric from a log or a trace. As long as there's a number in the log file, you can say, parse the log and pull out this metric and then use it as a metric in my metric system.
Okay. So
in theory, a trace and a log are the same. A trace is really a structured log.
Like a series of logs?
No, it has a defined structure. So one of the biggest problems we have with logs is that you can just generate them in any way you want. So the format is not consistent. So if you were to tell me, look at this log file and tell me what the error is that the application's giving you. Every kind of application generates different types of errors, and every programming language generates different errors. So it's totally non-standardized. And so what OpenTelemetry does is it creates standards around, especially around tracing, but Jaeger is always, in distributed tracing, is always required structured data so that we can make sense of it. And that's why the value of distributed tracing is much higher than any of the other data sources because of the structure that those have. It doesn't mean you don't need logs and you don't need metrics. They're super important for various use cases, but tracing is always structured.
So is Jaeger the one doing the structuring, or is structuring happening as part of the OpenTelemetry collection?
OTel does the structuring.
OTel does the structuring. Okay.
Yeah, and makes it standardized.
So if I'm a human and I want an open source observability solution, I want to build it myself.
Yeah.
Do I pick a logging project like FluentBit? I pick metrics like Prometheus. I picked Jaeger for logs. I use OpenTelemetry to standardize the formatting for all of the things. Did I do it? What am I missing? What do I have too much of?
Yeah, so like FluentBit and OpenTelemetry are overlapping and somewhat competitive with each other. They both do data collection. They don't do data storage. They don't do any of that stuff.
Okay. Yeah,
so
we talked about that a little
if you want tracing, you have to basically use OpenTelemetry, which can do logging and metrics as well. If you don't need tracing, FluentBit is great because it does logs and metrics and it's simpler to operate and use. But the backend still needs to be defined. Even if you have logs, you need to put them somewhere. So
is it an either or thing? Can I have FluentBit for logs and do OpenTelemetry for tracing and Jaeger for tracing? Okay.
Yeah, you can. But then you're kind of overlapping things a little bit.
Okay.
Because OpenTelemetry also can do logs. So
yeah. And
if you're already
can now do
using
tracing
it,
too.
you should just use it.
I think. Yeah.
But you have to pick the back end. So the open source stack that's most common is Prometheus for metrics, which can come from OpenTelemetry, Jaeger for tracing, which can come from OpenTelemetry. For logging, there's a lot of popular tools. Probably the most popular is Elasticsearch and OpenSearch. Those can both take data from FluentBit or OpenTelemetry, and they deal with log data. Loki is very popular as another open source logging backend by Grafana Labs that people use that's pretty low cost and pretty efficient. But you can mix and match and choose, what you want to use and move in between things. So
the processing of the data happens at the OpenTelemetry collector level.
Well, I mean, processing happens all over. I mean, it happens in multiple places, but yeah, I mean, the OpenTelemetry collector collects the data, processes it, and then sends it to another system, which then also processes it and stores it eventually.
Okay.
Yeah.
So we have a question from Napalm.
Sure.
In Greenfield, should you not use logs at all instead of traces? It's a little bit what I'm asking too.
So I've seen a lot of users that decide to stuff all of their logs inside traces, which you can do, but it can create performance problems because, as I mentioned before, logs can be very verbose and filled with junk that's not useful. So you have to be careful, but ideally, if your traces are really good, then the use of logs is not particularly helpful. The one thing that you have to keep in mind is that a lot of applications don't deal with interactive things that users are doing. So even though I'm clicking that checkout button, maybe at the end of the day, there's a reconciliation process that happens, a batch process. Logs are really useful for things that are not interactive. So any parts of your application that are maybe running on a time cycle, end of the month, end of the week, end of the day. Think about the stock market, they reconcile all those trades. Tracing is sometimes not the best thing to use for batch processes. And oftentimes logs are going to be more efficient because you don't really necessarily have the need for distributed tracing in kind of batch processing. But it sort of depends on the use cases. I mean, I can give examples where logs make sense and where traces make sense. Ideally, you have some of both, and ideally they don't overlap, so you're not wasting money on storing the same thing over and over again.
So traces are good for when there's interaction.
Yeah.
Like when the user's interacting with something.
Or an API interacting with another API. It could be something like that too. It's more like real time is what traces are good for. And logs are often more useful for kind of batch processing or non-interactive kind of processing. But you're running a database. Let's say you're running Jaeger and you're running ClickHouse. ClickHouse generates logs as well, which are useful. The operating system generates logs, which are useful. Your infrastructure generates logs, which are useful. There's lots of other logs that are generated, but in your application, likely tracing is going to be higher value than logging.
Okay. I'm starting, like, it's dawning on me how much I don't know, how like vast and complicated the world of observability is. And it seems like these projects can be used in tandem or alone, or they're all growing too and overlap a little bit. And it's hard. Yeah, I'll wrap my head around in a few months after I do enough of these, but I'm starting to see how much I don't know. Is a good place to take it from here in terms of what we've covered? What do you think is good to talk about? Before I have one quick question. I want to make sure I have a clear understanding of something. Jaeger's input is open telemetry data that's collected from applications, and Jaeger's output is storing that data in one of these. Are these called backends? Jaeger's called a
backend or database or whatever you want to use. They're both totally fine terminology.
Okay. Jaeger's output is a storage and then also visualization where you can ask arbitrary questions of your system.
Yep, correct.
Okay. Is the UI the only way to interface with the data?
No, we have all kinds of APIs that people can interact with the data programmatically or integrated into other systems. So some tools will read the Jaeger format and they can use it for other things. It's all open standards based. So.
Okay, I think that's important to note.
Yep, definitely.
Because in my mind's eye, I was just imagining it feels like a lot of work for a dashboard, which I'm sure it's a very valuable dashboard, but yeah.
It's not really for dashboarding. It's more that it has its own way to search for data and interact with the data.
Okay.
So we have some dashboards, but they're more part of that SPM piece that I was talking about. That's really where there's a dashboard that shows you your application performance. Jaeger itself is more of like search and analysis in general. So it's less about a dashboard and more about like finding the needle in the haystack, so to speak, which is I'm looking for this specific issue or this specific, part of my application, and I want to understand what's happening there. So it's more of a diagnostic tool and a way
Okay.
for people to really, dig into what their application is doing and how it's performing.
I have a question for you. If you had a distributed application and you were designing an observability solution in a
Yeah.
greenfield way, in an open source greenfield way, how would you design it?
It's probably going to depend on the volume of the data and the type of business that it's in. I mean, so it's hard to really provide a generic answer to that one.
Okay.
I mean, I like the use of some of the Grafana technology that they have. I also like OpenSearch. And then I think ClickHouse has a lot of great efficiencies. So it'd probably be a combination of those technologies coupled with Prometheus, most likely. So it'd be something like that.
I'm gonna go to little. So all the Grafana stuff plus Prometheus. Where does Jaeger?
Well, I mean, that's part of the Grafana. I would pick and choose pieces of Grafana, and then Prometheus, along with ClickHouse and Jaeger. Probably something like that, but at case by case basis. And it depends on the scale too. I mean, if it's a relatively small company or a startup, then you can cut corners on some of the stuff, but at scale, it becomes a much bigger problem to solve. And if you have budget, there's great tools out there too. So you can pick and choose some commercial, some open source. It's pretty common to do a mix of both of those because there's some commercial tools that make things much easier, of course.
That makes sense to me. I'm ready to buy some right now. Okay, so I captured like this inputs outputs thing. Instead of just visualization, I put visualization performance troubleshooting. How does that sound?
Yeah, more like use cases. Yeah, that makes sense to me.
And then do you think part of Jaeger's
it's a little simplified, like the Jaeger box is a few different pieces, but we don't have to go into the details there.
Do you think Jaeger is best used would it be good to represent more than one app? Is Jaeger helpful in understanding what's going on between applications?
Yeah, of course. Yeah.
Okay.
So ideally, you have lots of different applications all going through sometimes layers of open telemetry because in order to scale it, you actually need multiple open telemetry collectors. And then ideally, they all send it to the same backend so that you can really visualize what's happening there.
So I think that's the value that I was kind of missing before, which of course is implied in the distributed part.
Yeah, each of those pieces of the application that make up the spans are basically each submitting their part of the transaction to the distributed tracing system. So when you see a trace that has a gap, that means that your instrumentation is missing somewhere, if you know what I mean.
Yes. Input, output. Okay.
Yeah, it looks good.
Yeah. I'm very happy with that. Cool. Thank you for helping me understand that. So now back to the question I asked before. Oh, Code with Sean's here. Hello, Code with Sean. Good to see you, friend. The question I asked before was, what do you think is important to cover next?
I mean, if you want to talk about kind of like where the project is going, we can talk about that. There's a lot of other kind of supporting pieces to the project that we can talk about, like how to deploy it, how to scale it. There's lots of, kind of like more in-depth topics around Jaeger itself. It's super easy to get started and run it on your laptop, but when you start running it on thousands of applications, it can be a lot more challenging to scale it. So we kind of help with all of those scenarios, from how do I play around with this? How do I spin it up easily and in a Docker, set of Docker containers on my laptop, all the way up to, highly complex systems where you're dealing with queuing and all kinds of other scale challenges that come along with it.
I think what will help me is, if this sounds okay, is like use cases. Like, I'm a company, I'm having these problems. What's Jaeger solving for me exactly?
Yeah. I mean, any company today deals with distributed systems and lots of dependencies.
Yeah.
But as soon as you start having multiple development teams, which is like more than 10 engineers, basically, then you start getting finger pointing of like, where is the problem happening? How do I debug the problem? So a lot of it is around actual troubleshooting of like finger pointing. But it can also be dealing with vendors and dealing with, just kind of where the problem is happening is probably the highest value in terms of use cases, but it can go a lot beyond that point.
Can you tell me a story about like a place that didn't have Jaeger before and it's implemented Jaeger? Can you bring it to life for me? Give it some color.
Yeah, sure. So when you have multiple teams in today's environments, you own the end-to-end component of that microservice. So you build it, you run it in production, you're responsible for it. Someone on your team is on call for it. Now, the challenge is when you have a big problem, like I mentioned before, my checkout isn't working. My customers are clicking the button, it just spins and sits there and nothing happens. So who do I page? Like, who do I wake up? Where's the problem? The old way we used to do it is to open a war room conference call and page everyone and say, okay, you 25 people get on the phone and talk this through and figure out where the problem is. Like you have to all get together and figure this out. And if you don't have data, everyone just looks at their own view of their application component. And oftentimes it takes a while for someone to say, oh, I found a problem in my application. Maybe this is it. Let me make a configuration change or a code change, deploy it to production. Did I fix the problem? Yes or no? No, you didn't fix it. Okay, let's go find something else. So it's like, without this data, it becomes really hard to understand where the problem is happening. So as we continue to break applications into smaller parts, this problem becomes exponentially more complicated to debug. So when you went to these companies that pioneered microservices like Uber and Netflix and Amazon, they saw this problem long before everyone else, and they built, and Meta, they all built extremely complex, sophisticated distributed tracing systems to solve this problem.
So if you had only logs, what are you doing to try to solve the problem? If you had only logs and metrics without traces,
well,
what does that give you?
Each team that owns a component of the application would look at their silo view of their logs and metrics
Mm-hmm.
and try to figure out where the problem is. You can use some network devices to potentially help you figure it out, because a lot of network devices collect things like latency, like response time. So I can start to see things on the network sometimes when they're happening, but it's not at all easy to translate the network data to the application data. So
this is very helpful.
yeah.
Cool. All right. And then you kind of talked about, I don't know if you want me to capture this on the board. You talked about scaling and how these two pieces can scale independent of one another.
Sure.
We can go into that a little more. We could talk about what's coming up for Jaeger, which that sounds pretty interesting. Maybe a little bit of each.
Sure. Yeah, we can do that. The scaling thing gets a little more complicated, but
oh yeah.
Well, because it adds more components into the nice diagram on the top there. So yeah.
Yeah. Either way, if you want to get into those components, I think that's great.
Yeah, we can do that for sure. Yeah.
So, and the components are mostly related. I'm zipping up my shirt so I have more room on the board.
Okay, got it.
So there's the components of Jaeger. Are they specifically broken out into those components for the purposes of scaling?
Well, there's a lot of components in that Jaeger box itself, depending on how you scale it. So you can start breaking those pieces out of the Jaeger box, depending on what your needs are in terms of scalability. And the other thing is that the databases themselves also have to be scaled, which is another big problem that you have to deal with. So, running a simple cluster for Jaeger is fine, but as you start to scale that cluster out, you have to start introducing other components onto the storage layer to deal with that scaling. So a really common pattern that you see is, as people start scaling, they introduce things like Kafka, which can help queue data when the databases are busy. So it kind of gives a buffer for the database to keep up. So one of the first things people do is they put Kafka into the architecture that can help deal with, call it, databases that slow down or bursts of traffic, a lot of data coming in that can't be processed, kind of gives you a buffer. So one of the first things people do is add a queuing system like Kafka into the mix that can help deal with that burst of traffic or the pressure that the database is feeling.
So applications generate a lot of information.
Yep.
And it can't get it into the databases fast enough sometimes.
Yep.
Okay.
So in that Jaeger box, there's often a few different components that go into there, one of them being a queuing system. And OpenTelemetry can interact also with the queuing system. So there are ways to kind of process that data and deal with, you see queuing systems like Kafka in a lot of observability solutions, because it's a big scaling challenge to deal with. So it gives you a lot of flexibility when you have something like a queuing system in the mix.
So are you saying Jaeger has its own queuing system built in? No. You're saying people add a third-party queuing system.
Kafka is the most common open source system to deal with that type of thing.
Okay.
So, and OpenTelemetry works with Kafka as well. So it's pretty common to see that as people start scaling, or, when people come onto the channel and say, I'm missing data, or, my database is too slow. One of the first things that we do is say, hey, have you thought about putting Kafka into that architecture to make it more resilient to those bursts, that you run into that are pretty common.
Cool. What other challenges are there when you're scaling Jaeger?
So one of the other ones is that on the open telemetry side, so you see how you have all those 3 different collectors on the top, the 3 little OTel. So how you architect your collectors and how those flow, oftentimes you have to create tiers of collectors. So sometimes those 3 collectors might send to another collector, which could send to another. You end up kind of like tiering it based on what you're trying to do. And each of those layers actually does different aspects of the processing. So that can become a lot more complex just in the way that you architect the data collection from OTel, which will have a lot to do with how the data is reported to Jaeger, what it looks like in the database, how it gets visualized. I mean, all of that stuff has a has an impact on the overall system.
And so how does Jaeger help with that in particular, or is it just something to consider?
It's something to consider when you're scaling Jaeger. As Jaeger grows, your open telemetry grows as well. And there are things that you can do in open telemetry to make it more efficient. Kind of going back to that sampling discussion, what you're doing for sampling, how you're doing the calculations and filtering. A lot of that is going to impact how much data ends up in that database, what it looks like. That's going to impact your cost, and that's going to impact the performance of Jaeger itself. So sometimes people come in our channel and say, when I run a search on Jaeger, it takes 2 minutes to come up. It's like, well, obviously something is not running very efficiently. And then we can start asking them questions like, how long are you keeping the data for? What does the architecture of your database look like? How is your open telemetry architecture look? These things are all going to impact, the value that you get out of the data that you're storing there.
So this is a common bottleneck.
Well, yeah, I mean, it's a big data problem, like any kind of observability. And if your team isn't good at scaling big data and dealing with big data problems, then, you ask the community for help. We try to help, but it's like, there are people that spend lots of time dealing with this stuff. And going back to the other mention, if you go to a vendor, they'll help you deal with these kinds of problems. If you're running open source, all of us people in the Jaeger channel do our best to answer your questions, but we all have jobs and hobbies and families and stuff like that too. So it's, we're going to do our best, but, we're doing this as volunteers.
Yeah. Thank you. Do you have anything else you want to say about scaling Jaeger?
I mean, mostly the Kafka piece is kind of the big part of it. And then, a lot of it's OTel. So as was mentioned earlier, I mean, the sampling discussion is a big one.
And then Jaeger scales horizontally. You were saying, and
yep. So
and only I
mean, most of it is really about scaling the ingestion, which is the data coming from open telemetry, and then scaling the storage, which is basically the back end. That covers almost all of it. The visualization is pretty simple. All it does is makes queries to the storage. There's nothing too sophisticated there. It's mostly about scaling, the stuff to the left of your Jaeger box and then the storage on the right-hand side. So a lot of the sampling strategy in open telemetry impacts the cost and the performance. The better you sample, the less data you store, the cheaper it is, the faster it runs. So
cool.
Yeah.
Well, we're about out of space on the board. We have like a little, I could sneak in a couple things, but is there anything that you feel like is important to capture about Jaeger, or something about the story that we didn't touch today?
I think the story is pretty good. We didn't talk about any of the future stuff
Yeah.
that we're really doing. I mean, that's probably kind of the other thing.
I can add a couple things about the future. I can find space.
Sure.
Regardless, we should talk about it.
Yeah, definitely.
What's cool happening with
So
Jaeger in the
later
future?
this year, we've been hard at work probably for the last year on building what we call Jaeger V2. Everything up until this point since Jaeger was started all fits under version 1, which basically means that it's generally backwards compatible. But we're making some changes to the project, which has been ongoing. I can't remember when Jaeger was created. I was just looking it up. But, this is going back, many years since Jaeger was built and obviously became part of the CNCF. So what we're doing is, if you look at your little architecture diagram on the top, more and more of open telemetry is becoming a key part of how Jaeger functions. And now we're actually making it much tighter integrated. Because when people get started with open telemetry, they almost always use Jaeger to visualize the data. It's basically the de facto user interface for looking at trace data. And so we're making it even easier than it is today. So we're replacing components of Jaeger with open telemetry. So up on top, open telemetry can interact directly with storage systems. It already does that for many things. And so we're actually replacing the Jaeger collector, which is the main part of that box that's labeled Jaeger, with open telemetry, basically. It's a specialized, like, we're building our own custom distribution, but we won't have to maintain all of the code in the collector. Instead, it's mostly a configuration where we can actually run the visualization and do the storage processing inside open telemetry, running a specialized configuration of open telemetry. So, and that requires a lot of other changes that are happening both in Jaeger and in open telemetry. We're pioneering some new components to open telemetry. We're building a lot of new stuff in both projects. And the goal is to just make it even more tightly integrated.
Jaeger is the de facto way to visualize OTel trace data? Is that what you said?
Yeah. So if you're a developer getting started and you want to look at what your traces look like, most people will fire up Jaeger on their laptop, collect the traces, and visualize them. I mean, it's kind of the standard these days. We have super simple Docker container that fires up Jaeger, and even an application that generates traces, and you can try it out yourself really, really easily and get started on your laptop and run all of this stuff together. So
cool.
Yeah.
So Jaeger V2 coming soon, tighter integration with OTel. Do you want me to say something more specific about that?
I mean, we should have a beta out towards the end of the summer. We're doing, aside from the team of maintainers doing work, we're definitely taking on contributors. We're running also mentorship programs. So we're participating in Google Summer of Code, which is starting now. We participate in both semesters of the Linux Foundation mentorship program. And we're always looking for contributors. We get a good amount of contributions today, but we definitely want people to contribute regularly. We want people to become maintainers of the project. We definitely need more help from the community because, as I mentioned, it's all volunteer, and we all have day jobs, and we want to make sure the project is viable.
If someone wants to contribute, where should they go? What should they do?
So you can look in GitHub. There's some issues that are tagged good first issue. Those are always easy ones to tackle. Jump onto the Jaeger Slack channel. where we have lots of interactions. Just ask, I'm a first-time contributor, what should I work on? Or is there something I can help with? If you see an issue with the documentation, you can submit a PR. If you see a bug, you can submit a PR. We get a lot of those. We have a presence at KubeCon. So we usually have a kiosk at KubeCon. You can come and talk to us there. We do a talk at KubeCon. We try to, keep it going and interactive. There's only about 15 or 20 graduated projects in the CNCF. Jaeger is one of them. So we're very mature. We have a good user base, proven technology, and it's very stable. So it's a good community to be part of. And it's a huge, complex problem with lots of different vendors and people involved in trying to solve it. So it's an interesting space that there's lots of innovation left in.
Cool.
Yeah.
So the way I'd like to close this out is that I would like to repeat everything I learned today to you to verify it's correct on the board, and that that we told the story like we like to. So before Jaeger existed, software was getting broken into smaller and smaller pieces, and this is before microservices even. This is with Java, because Java is multi-threaded, right? So
yes. Yep.
Yeah. So we're having distributed applications before we had like entire distributed systems. So, but then we did have the entire distributed systems, and we added microservices, and that problem got even more complex, and it's it's mind-blowingly complex. So then that's the world where
the one thing to add there is that not only did we make it more complex, but we made those changes so that we could empower these small teams to own the application. When the application got really big, you can't have one engineering team with 100 people working on it. That's what we used to do. Today, we now want 8 people in engineering teams owning pieces of things so that they're empowered to own it from end to end. That's really what the DevOps movement is about. So we needed to change the application construct to actually match the organizational construct that we wanted. And that's the reason why we built microservices, is because we wanted to move faster and empower those teams. So we didn't just do it because we want to make things more complex. We did it because we know that users, the organizational construct of people collaborating needs to be in small teams managing discrete components of applications.
And part of the small team owning their piece of it is them being able to understand what just their piece of it is doing.
Yes.
And so that's why the observability piece and the tracing piece is important. So you taught me an acronym that got thrown around quite a bit, which is APM, which is application performance monitoring, related to what we just said. And so one huge component of APM is distributed tracing. So Jaeger then is a distributed tracing system designed to collect, visualize, and store traces. And specifically, it leverages OpenTelemetry, which we'll call OTel, to instrument apps. Everybody calls it OTel, not just us here.
Sure.
To instrument apps to generate data that Jaeger collects. So we have up here in this diagram, we have many applications. Each are instrumented with OTel. OTel sending that data to Jaeger. And like you mentioned before, this is simplistic. OTel might send to other OTel collectors, and it might be more of a tree. But it's sending data to Jaeger. And then Jaeger has 2 main outputs. One is it's putting that data into storage, and it officially supports Elasticsearch, OpenSearch, Cassandra, and ClickHouse is coming soon. And there are also many unofficially supported that the community has made. And then it does visualization, which is a UI that helps you analyze, understand, and troubleshoot tracing. You can visualize your application topology. You can do service performance and monitoring, which utilizes tracing to derive metrics and then to store it in a metric system. But also with this visualization piece, it can also be data that you access via API. It's not just a UI. So that's skipping ahead a little bit. Before, I wanted to talk about just what even is a trace. So a trace is an end-to-end transaction. So an example would be somebody's checkout transaction. And then each step of a trace is called a span. So a span might be doing an API call to UPS to generate a shipping label. And these traces help you understand what an application actually does, as so much is getting complicated and you're reaching out to different pieces of the application that are managed separately, but also to entirely external API calls. Having a holistic picture of what's happening getting increasingly difficult. So that's what tracing is for. Tracing is very valuable for performance. So you can see what's lagging, you can see what's timing out, you can pinpoint where your problems are, which is what we talked about here. So we said the problem, we have multiple teams building different aspects of the same application. And where that's a problem, it's very hard to know where that problem is. So you said they used to get everyone in the same room to have a discussion about it, or on the same video to figure out the problem. So then it seems like with all of this data, if you're able to collect so much information about every little granular thing, there must be a compute cost with that. And you said that compute cost comes mostly from the storing aspect. So sampling is used to reduce the amount of data collection, the data that needs to be adjusted and stored. But this is something that's done.
And network also plays some impact, because obviously when you're dealing with high scale, you can introduce a lot of network traffic, but generally storage is the bulk of the cost.
Okay.
Yeah.
Okay. And so storing and some from networking.
Yeah.
And then I'd write it, but there's no room.
It's okay.
And so, but this is solved. The sampling part is solved more with OpenTelemetry than with Jaeger.
Yep.
But Jaeger is the de facto way to visualize OpenTelemetry trace data. We talked about kind of like observability more, like zoomed out a little bit. Like if you have traces, why do you need logs? And logs are good for non-interactive transactions or for batch processing or for batch processing. And traces are good for knowing interactions between apps, between APIs, between a user and an app, just like interactions. We covered this. So then the last thing we talked about then was scaling Jaeger. So this can be a difficult problem because apps generate lots and lots and lots of information, and the databases can't receive it fast enough sometimes. So how do we solve this? So folks will add a queuing system. You said usually Kafka to solve this problem of back pressure. Is that, yeah.
Yeah.
And then OpenTelemetry collectors, I represented them very simplistically here. They can get tiered, and that can be, so sometimes the way your OTel is set up is something that could be a bottleneck to your system that could be slowing things down in terms of the Jaeger piece. So that's something to look out for when you're scaling. And then also you're considering scaling your ingestion, like your OTel collection is a separate problem than scaling your storage. There are two pieces of Jaeger to consider when you're thinking about scaling Jaeger. And then finally, we talked about coming soon is Jaeger V2, which is going to bring tighter integration with OpenTelemetry. And please contribute. You can go to the Jaeger channel of the CNCF Slack. You can find Jaeger on GitHub, or even the Jaegertracing.io will tell you where you can.
And we have a cool logo too.
Oh yeah, what's that Gopher doing? Yeah.
What's that?
You have a gopher. What's the gopher doing?
I don't know. He's looking at
cool.
something. I don't know. It's a cool logo. It's like very Ren and Stimpy, you know, for us old people.
That's me. Cool. Well, I'm going to dance our goodbyes. Feel free to shake it a little bit, Jonah, but don't feel like you have to. Thanks everyone for coming. Thanks, Jonah, for sharing your time and expertise. Thanks everyone in the chat for your great questions. Thanks to those who watched the recording. Bye. Take it a little, Jonah. Just give me a little. Yeah. Awesome. Bye. Thank you.